because you only have these enolates that are available, right? You can also have tertbutanone, right? Just like the tertbutanol over there, because again, it only has one source of alpha hydrogens. And then specifically, aldehydes, right? So if you have an aldehyde like ethanal or propanol, so anything over here, right? At least 2 alpha hydrogens over here, that can only go with formaldehyde, right? But that is a possibility as well, right? So again, E components are, usually carbonyls with no available alpha hydrogens, and new components are carbonyls with one source of alpha hydrogens. They always form the same enolate, okay? So let's get an example of how that would work.
He asked the question on the quiz where he gave ethoxides on each side. Like everything had an ethoxide on it.
Okay, so it wasn't an ethoxide, those were esters, and that was a Claisen condensation. That is a separate thing.
No, he had a carbonyl with an ethoxide on both sides.
Yeah, and
That's an ester?
that's a diester, right? And that has to do with Claisen condensations. That doesn't have to do with aldol condensation, or it has very little to do with it. Okay? Whereas an aldol condensation makes, a conjugated carbonyl, something like this, right? A Claisen condensation will make a 1,3 dicarbonyl, like this, okay? But maybe we'll get there tonight, maybe we'll get there when I come back, okay? Either way, moving right along, right? So that is the Claisen condensation, okay? So how would that work? So for example, right, if you have pentanone, right, cyclopentanone, right, and not sure exactly what you call this, some sort of furan with an aldehyde, right? So as you can see, the ketone component only has one source of alpha hydrogens, right? And the aldehyde component has no sources of alpha hydrogens. There are no alpha hydrogens there, right? So how does this react exactly? Okay, so the aldehyde component is the one that's going to be attacked. This is going to form the enolate. Let's draw a little mini mechanism to help us understand this, okay? So first let's make the enolate out of this. We're not going to draw the mechanism because I don't want to. Okay, so this is our enolate, right? This is our E component, right? E component, everybody see? They correspond together. Now we're going to do our little mini mechanism. So, lone pairs come down to reform the carbonyl. This attacks the carbonyl carbon for the aldehyde, which goes up onto the aldehyde, right? So at this point, we have something that looks like this. Carbonyl, right? And then O negative over here. I mean, depending on, what conditions we are, that could be an OH, right? This is what we have at this point in time, right? This gets protonated, let's say, by water, right? And we end up, for our aldol addition, we end up with this, right? This is specifically our aldol addition. Okay, specifically the aldol addition. Now condensation, right? First off, is it possible to do condensation here? What are the prerequisites for condensation?
No alpha hydrogen.
2 alpha hydrogens. So is it possible to do condensation?
No. Wait, are you talking about the original?
Yeah.
Yeah.
What does it have over here? You have how many alpha hydrogens? 2, right? So the condensation is literally just getting rid of the OH, right? And replacing it with a double bond between the alpha and the beta carbon, okay? Okay, that would be our condensation product, okay? So that's the example of a Claisen-Schmidt condensation, right? A Claisen-Schmidt is, sorry. is in, what? You still got my head?
Yeah.
Lucky you. That's an example of a condensation between two different types of carbonyls, right? And the reason why that works is because one has only one source of alpha hydrogens and the other has no sources of alpha hydrogens. Now, keep in mind, this always happens in the presence of a strong base, right? At this point in time. A strong base at this point in time. Okay? Moving right along. So let's do a small problem for this. No problem, thank you. Great night.
Good. Yeah.
Don't worry about it.
Yeah.
I'll be here like 15 minutes.
Yeah.
Don't worry about it, okay?
You already showed me all this stuff. We went over it.
Yeah.
I just needed to sit down and do it.
You're good. Yeah, that's it. You need to sit down and practice that.
You last for the first time before.
Don't get discouraged. You're doing great. Okay, that's all I can tell you. Thank you.
Before anybody else sees anything more. Alright, good luck, guys.
Okay. What?
I've been here for like 30 minutes, I guess we're good too.
Oh, come on. Guys, he's here for like 10 minutes. You just
I know, I
I'm
know.
not gonna
I
do
know.
that. I'm not that cool.
Any, we're recording again in case any other blackmail has to happen.
Oh, fuck you. Either way, fine. So let's see a good example of how that works. All right. I just want to give you guys an example. Actually, he had a question like this on the quiz we did before, right? So sometimes he'll ask you to predict the products of a reaction, right? So he'll give you either one or both of the products and ask you to make a certain reactant, right? Or he'll give you something like this, right? And we had something like this on your quiz. That's a bromine.
It's a beautiful bromine.
Thank you. Bromine, right? So, and he'll ask you to identify the starting materials, right?
So is this, I could be wrong, but is this where we do you identify the alpha and the beta,
Yeah.
and then you
But
break
first
it?
off, you have those two bromines there. So what does that automatically mean? Right? There was an alkene there, right? The only way that you could add two bromines adjacent to each other like that is if there was an alkene there before.
And what would
right?
you use to add that?
BR2.
BRT, right, okay.
Right, so first, retrosynthesis, BR2. Seriously?
Just draw
Okay.
a freaking circle inside.
No.
Stop with the double bond.
No.
You don't have all day. Actually, we have all day.
The day's gone.
Please draw a freaking circle and move on with it.
Guys, at least you get to sit down. I didn't think I'm doing this thing over here. I like stretch out my hamstring. Oh my god.
You could have stole a rolly chair. No one stopped you.
What?
You could have stole a rolly chair.
I'm a tough person.
He just finished.
Okay, so at this point in time, this is where you identify alpha and beta, right? Towards the double bond, of course, right? So this is going to be your alpha and this is going to be your beta, right? And basically you just cut these two bonds right here, right? You replace
That
a
would be
aldehyde or sometimes a ketone on the beta carbon, all right? Depending on
I
which
thought
one.
you have to add a hydrogen to the alpha. Do you not have to do that?
You do, but I just shorthand it. Like, I mean, at this point, like, it's understood that there are hydrogens over here.
Okay, so
You know what I'm
there is a
saying?
hydrogen
There
present
is,
there.
yeah. But like, I mean, if you would just cut that short and just say like, all right, just add, just cut the two bonds between the alpha and the beta, so the alkene, then, I mean, if you want, you could do it a little bit longer, right? So you have your double bond here, right? So sometimes you can just cut the double bond, right? Add the OH, right? Then cut this bond over here, right? And add the aldehyde, right? So now it's understood that you're adding those hydrogens over there, but I just skipped those steps because it doesn't make a difference.
I'm talking about the adding a hydrogen to the alpha, not the beta.
Exactly.
Okay,
Yeah,
We're on the same
that's
page. Cool.
like understood, right? This is just like a shorthand way of doing it, like automatically, because that's usually what you're gonna do in these cases. Just cut the bonds, move on, right? Okay. So up until now, this has been Clays and Schmidt. All right, moving on to Novonagel. All right,
I have a question.
Go ahead.
Is the Clayton
cross Clays and condensation.
is that something different?
That is something different. That has to do with esters. Okay.
That's the addition of two esters together.
That's just the addition of either two esters or a ketone with an ester or, something like that.
It's basically the most complicated structures coming together.
Not necessarily. It
That's
doesn't
what
have
it
to be
seemed
so
like on the
complicated.
quiz.
I don't know. It's, don't worry about it. I mean, worry about it, but like, for now,
He had a question about that on the quiz, that's why. About what?
right, yeah, I know that,
Oh,
that's probably gonna be on the next exam. But, I mean, right now, like, we have to go through Novonagel, or we don't have to, it's really your choice. Like, I'm just going in order, I'm just, following the chapter. But if you guys want me to skip over to clays and condensations, right, we can do that as well. So, at this point, we're at Novonagel, right? And again, we're separating our compounds into E components and new components, right? So, E, new, right?
My bad.
Whatever you want, yeah. It's all good. So, E and new components. Alright? In the case of a Novonagel, right, and this might surprise you at first, don't get too afraid, right? You can
How do
use
I spell?
And wait, can I try?
that's actually extra credit on the exam.
Can I try?
I swear, if you spell
K-N-O-V-E.
Novonagel on the back of your exam, plus 3.
How?
I think it's K-N-O-E.
V-A-G-E-L, something like that.
Okay, either way, so the E component for Novonagel, surprise, is any aldehyde or ketone. Okay?
Any aldehydes or ketones? Really?
See, I told you you're gonna be
Because
surprised.
that's not what the chapter is about at all. It's just so random.
It's ridiculous, right?
Ridiculously random.
Any aldehyde or ketone,
Yeah.
but the new component has to be a compound with relatively acidic alpha hydrogens, right? So what does that mean? That means our beta keto esters, right? It is our 1,3 dicarbonyls, right? So beta keto esters, right? 1,3 dicarbonyls, so anything that looks like this, right? Just, a diketone like that, right? As well as carbonyl analogs, right? So what do I mean by carbonyl analogs, okay? So it can also be two nitriles attached to each other, right? Or two NO2s attached to each other, right? Or a combination of these, let's say 4 things that you have. So you could have a ketone, right, with a carbon in the middle and then a nitrile, right? Or you can have an ester over here and a nitrile, right? Any of these two combinations, as long as you have an alpha carbon in the middle with 2 hydrogens, or with 1 hydrogen really, it doesn't need to be 2, right? They can do, well, it needs to be 2 if you're doing the condensation, but they can do this enolate reaction, this aldol addition, or an aldol condensation, right? So that is the Novonagel. Now Novonagel is very easy to recognize, okay? How would you recognize Novonagel? Well, first off, right, let's say we have this problem over here. Okay, one way you could automatically tell it's a Novonagel reaction is what?
The CN.
That dicene,
dicene.
right? So you have 2 you have two carbonyl analogs attached to each other with one carbon, right? So, in this case, what would our new component be? The CN, right? What would our E component be? The other one, right? What would our product be over here?
A combination of both.
Math.
This is the first one.
I think Riza's done.
Tuesday, yeah.
She's the one over the edge. That's like a first for no monogamy, that type of reaction. No, you're far from that. You could put in so much more, you have no
Really good
idea.
grade on the-
Like, I've been there, you know, and further.
Oh, because of the quick grades.
Imagine advanced chemistry cooking. You're like wasted off of like some Adderalls. No, we're not. Stop taking pictures of me. Okay, so what does this look like?
I
All right.
have a picture of you dancing over there with good.
Really? Nice. You should put that all the way at the end of your presentation. And this is our TA.
Yeah, like a gift.
Actually gonna be.
That'd be awesome.
When she says turn on the light. It's so fucking good.
That'd be
I wish I
amazing.
had done this last semester.
Okay. I'm not sure what they would think about that. I would think it's hilarious. I'm not sure what they would say.
I'm not sure that they both have sense of humor.
No, you're right. I don't think they do.
They
No,
don't.
no, not at all, no.
Okay, so what does this look like exactly? Sorry about that. Right? What we're doing over here is we are, let's draw another, pseudo mechanism over here. So, well, like we said, our new component is the dinitrile, right? And our E component is this random pentanone, right? So, first off, right, the enolate that we're gonna draw over here is gonna look a little bit different, but it does the same thing, okay? We're literally just gonna put a double bond over there. That's how we're gonna draw it, okay? And this obviously is not really gonna change so much because it's our E